Hey guys, in this lesson we're going to be talking about factoring polynomials by grouping, and then we're going to be using the box method to do so. So the objective for today is we're going to be able to factor polynomials with the method of grouping, quote unquote, and then I like using the box method. So one of the things that you should consider when you guys are factoring polynomials is that if you want to use the method of grouping, you have to make sure that the polynomial has a total of 4 terms. Okay, so this is typically used when you have a polynomial of 4 terms. If you want to try to see if you can break things apart, if you can factor it into multiples of something with something else, then you need to make sure there are 4 terms total to be able to use this method. Okay, so the steps are the following. Step number 1, we need to take out the GCF of the original polynomial if applicable. So we already talked about how do we take out a greatest common factor. If there is a greatest common factor within the polynomial, we need to make sure to take that out first. This is going to be the first step for a lot of other lessons that I go through in the future. But you always want to check to make sure you can't take anything out as it is. All right, that would be the greatest common factor. Step 2, if you can't take anything out, or if you did already, step 2 will always be the same. It means to draw a 2x2 box. So for these next examples, I'm always going to have a 2x2 box to be able to take out the to be able to factor out with the method of grouping. Step 3, you need to write every term inside of the box, or I should say every single term inside of the 4 squares in the box. You can group them however you would like, meaning like if one configuration does not work out for you, or you can't factor anything out, you could always rearrange it or regroup it a different order to see if you can take something out that way. Okay. Step number 4, take out the greatest common factor from each row and each column of the box correspondingly. And then step 5, check your box to make sure that it makes sense. Okay, step 5 is really crucial. So step 5, you want to check your box and check your answer to make sure that everything does multiply out and that it does make sense. Otherwise, if you think you're doing stuff correctly, you may find out that you actually did it incorrectly because it doesn't multiply out to the original terms. Okay, so you always want to check your work. So what are we doing here? So I already have a couple of examples ready to go for you. So in example number 1, it says we want to factor out the polynomial x to the power of 3 minus x squared minus 25x plus 25, right? So the first thing that we should check is, can we take something out of it already as it is? So is there a GCF? Can we take out a greatest common factor as it is? So if you look at all the terms, so x to the power of 3, x negative x squared, negative 25x, and 25, there's no number that I can take out of all of them except for the number 1. So since we can't take out a greatest common factor besides 1, then no big deal. We just move on to the next step. Okay. So if we look at step number 2 says draw a 2x2 box. And then step number 3, which we just did already, I already have that pre-done for you. Step number 3, write every term inside of the 4 squares in the box. So let's do step 3 now. So what does that mean? So we're going to put the first term where it corresponds on the first section of the box. The second term will go in the second box. Don't forget the signs. Third term will go in the third little box. And then the last term will go in the last section of the box. Okay, so let's write that in. So this will be x to the power of 3, negative x squared, don't forget your sign, negative 25x, and then positive 25. So now I have put every single term inside of my box. So what is the next step? Next step is we need to take out the greatest common factor from each row and each column of the box. So we need to go through and check every single row and every single column to see what we can take out. We're basically doing multiplication in reverse. So if you're wondering, what the heck are we doing here? We're basically doing multiplication of binomials, but backwards. So rather than them giving you the binomials and you figuring out what goes inside of the box, this time you are given the box and you got to figure out what goes outside, meaning what terms times what terms do you multiply together to get the inside of this box. Okay, so that's what we're doing here. We're doing basically multiplication but backwards in reverse, which we call factoring. So step 3 says we need to check each row. Sorry, step 4 says we need to check each row and each column. So let's go through one by one. checking the first row. So that would be these two terms right here, right? If I check the x to the power of 3 and the negative x squared, what can we take out of those two? So the one thing that I can take out of these two is an x squared. So that x squared would go on the side of the box, on the left side, because it is corresponding with the x to the power of 3 and the negative x to the power of 2. Okay, so that'll be x to the power of 2. That is the most amount that I can take out of that row. Let's go down to the next row. The next row I have negative 25x and then positive 25. What number can I take out of those two? It needs to be the biggest possible, remember? Some of you guys might be thinking, oh, I can take out a 5. Yeah, that's right, but it's not the greatest amount that we can take out. So we need to take out the greatest possible, so we don't have to do any additional factorization after that. So the actual biggest amount that we can take out of these two is actually a 25, because 25 can be divided by negative 25 and 25. But since the first number is negative, I can also take out a negative from this 25, right? So keep a lookout, check out the first number. Typically, when the first number is negative, you should always take out a negative as well. Okay, so we're done with those two rows because there's nothing else that I can take out. I can't take out any x's because there's only an x on one term, but not the other term. So let's move on. This time we're going to be moving into the columns now. So we're going to be looking at this column, meaning the x to the power of 3 and the 25x. What can I take out of these two in terms of greatest common factor? Whatever we can take out, we put it on top. So here we have x to the power of 3, negative 25x. The only thing that I can take out of these two is an x, so I put that on top. That's the most amount that I can take out. I cannot take anything else out besides a 1, so I just leave it as is. Okay, let's work through the very, very last column here on the right side, and we do it again. What can we take out? The negative x to the power of 2 and the 25. As you can see here, the only thing that I can take out of these two, or the only thing that I can divide by both of these, is a 1. So I basically put a 1 outside, but again, keep a lookout. There's a negative sign in front of my first term, so I should actually include that with my 1. So I'm going to take out the negative 1 as well. Okay, am I done? Pretty much the hard part, yes, but the next step says check your box to make sure that it makes sense. Step 5 is critical. You want to make sure that everything actually does multiply to what it should multiply out to, right? So let's check it. So x squared times x, let me use a different color. X squared, if I multiply it with the x, I get x to the power of 3 inside. That works out. X squared, if I multiply it with the negative 1, I get negative x squared inside. So that does work out. Negative 25, if I multiply it with the x, I get negative 25x. So that does work out. Negative 25 multiplied with negative 1, I get a positive 25. So that also does work out. So yes, everything works out. So step 5 is checked. So we are happy with our answer. So therefore, our factors are going to be x squared minus 25 multiplied with x minus 1. That would give me the original problem. All right, so when I multiply these two things together, I get the original problem, which was x to the power of 3 minus x squared minus 25x plus 25. Okay, so we're doing multiplication, but backwards. So we're factoring stuff out. All right, so again, to be able to factor by grouping, we need to make sure we have a total of 4 terms. Okay, let's move on to example number 2. I have 3 total for you today. Example number 2, we need to factor this polynomial now. We have negative 9n plus 18 plus n to the power of 3 minus 2n squared. Notice that the order is all out of whack. So they're just all random places, right? So either way, I'm going to follow the same procedure as what I did for my last problems. So I'm going to put the first term there, second term there, third term here, and then the last term, which is negative 2n squared, right here. So let's fill in the box. Oh, wait, I forgot one thing, right? Can I take out a greatest common factor before anything? So the answer to that is actually no. We cannot take out a greatest common factor, right? We should always check first to see if we can take out a greatest common factor. That is step 1. If the answer is no, then we can move on to the next steps, right? So I kind of got ahead of myself. You should always check to see if there's a greatest common factor before moving on to the box. Now that we know that there is no greatest common factor that we can take out, okay, now we can move and fill things in the corresponding spaces in the box. So n to the power of 3 would go here, and negative 2n squared would go there. So let me fill out the box now. So negative 9n, 18 positive, n to the power of 3, and then negative 2n squared. Okay, now let's factor stuff out. So negative 9n, positive 18, what can come out of those two things? If you notice, I can take out a 9 from both of these. And not only that, the first number is negative, so I could actually take out a negative 9 from both of these because the first one's negative. All right, I cannot take out any n's because n is not shared with the 18. Okay, let's move on to the next one. So on the next row, I have n to the power of 3 and then negative 2n squared. The only thing that I can take out of these two right here is n squared. So I'm going to put an n squared here on the outside. Notice that my first number is positive, so I leave it as positive on the outside. All right, oops. Let's move on to the columns now. So here I have this column and this column. What can I take out of both of these? As you can see, the only thing that I can take out of both of these is an n, right? So these two things I can take out an n. That's it. And if you remember what I said in one of my previous lessons, I said, okay, if the first number is negative, take out a negative. So I'm going to go ahead and do that as well here. I'm taking out a negative. And then we'll come back to that in just a minute. Next thing, check the last column, 18 and negative 2n squared. So what can I take out of the 18 and the negative 2n squared? As you can see, the only thing that I can take out is 2. I can divide them both by 2. So I'm going to put a positive 2 in there. Okay? Now, step 5 is the crucial step. Now, notice that I followed all the steps correctly, right? But my step 5 says, check your box to make sure that it makes sense. If I check my box here, this is something that is not making sense. Something went terribly wrong. If I multiply this negative 9 with this negative n, I do not get a negative 9n. I want it to be a negative 9n, but it's not. This would actually give me positive 9n. So one of these have to change for this to make sense, right? If I multiply this n squared with this negative n, this also doesn't make sense because I do not get I do not get a positive. I actually get a negative as it is. So this does not make sense either. So what happened here is that this term on top should actually be changed to a positive n, or just n, for this to make sense. If I change this to a positive n now, all of a sudden my box is exactly the way that we need it to be, right? Negative 9 times n is negative 9n. If I check the second row, n squared times n gives me n to the power of 3. So all is well in the world now for this particular column. Let's check the next one. If I multiply the negative 9 with the positive 2, do I get 18? No, I don't. That is also incorrect. That positive 2 should change to a negative 2 as well for that to make sense. Let's see if that actually matches up with the rest of my box. 9 times negative 2 is positive 18 now, so that does make sense. N squared, if I multiply that with negative 2, I get negative 2n squared, so that does make sense. So, moral of the story is check your box. Make sure that your box makes sense according to the multiplication. Yes, you can follow the steps according to what I explained earlier with the greatest common factor, but it's not always going to give you the correct multiplication that you need. So you always want to check your box to make sure that it does make sense at the end. Okay, now that it does make sense at the end, now I can write my factors. So my factors are going to be negative 9, positive n squared, which I'm going to write as plus n squared, and then multiplied with n minus 2. If I multiply these things together, I will get my original polynomial. Okay? So hopefully that makes sense. You're probably wondering, like, why did this problem screw up in the first place? Like, why did it not make sense nicely and into my box? And the reason for that is because this polynomial is not given in descending order. Remember, for the polynomial to be simplified, it needs to be written in descending order. That should be n to the power of 3, and then minus 2n squared, and then minus 9n, and then plus 18. This should be the polynomial simplified in descending order, but in this case, they do not give it to you in descending order, so therefore, that's where we ran into some issues, okay? So if it bothers you, you could always rewrite it in descending order first and then do the box, but either way, it'll work out if you just check your box, okay? Example 3, the last one that I have for you is factor this polynomial. Now for this one, we need to go back to the steps. Step 1 says take out the greatest common factor of the original polynomial. For this one, be careful. There actually is a factor that you can take out of every single term. I cannot take out any x's, right, because the 8 doesn't have an x, but I can take out a 2 from every single term. So that 2 is going to go on the outside, which we call the greatest common factor. And then on the inside, I'm going to have whatever's left. So I'm going to get 2x to the power of 3 plus 1x, and then here I'm going to get plus 8x plus 4. So I'm basically doing the distributive property backwards to be able to take out that greatest common factor. Okay, notice that the inside here cannot be factored out anymore. So there's nothing else that I can take out of any of the terms. So I'm pretty much done. I took out my greatest common factor. Okay, so now inside of this parentheses, I can factor this out by grouping using the method that we just talked about in the last two examples. So let me put the 2x to the power of 3 in the first box. Let's put the 1x in the second box. Let's put the 8x in the third little box. And let's put the positive 4 on the last box. So what color have I not used here? Let's go with blue. All right, so 2x to the power of 3 went here. 1x went here, that was positive. 8x went here, that was positive. And then positive 4 went here. Okay, so same process for the rest of it. So we need to check each row and column to see what we can take out. So we check the very first row. What can come out of those two terms? The only thing that I can take out of those two terms is just an x. Nothing else divides into the 2 and the 1 besides a 1, so we can just take out an x from both of those. So that's great. We can move on to the next row. All right, let's check the next row. What can I take out of the 8x and the positive 4? The only thing that I can take out of those two is a positive 4, because those two things can be divided by 4. Again, be careful. You can say that you can take out a 2 here, but this is not the greatest common factor. We want to take out the most possible. So we wouldn't take out a 2, we would take out a 4. And since the first number is positive, we leave it as positive. All right? So this will be a positive 4. Let's move on to the columns now. So what can we take out of each column? So we do this column with this column and put it on top. The number that can go out of the 2 and the 8 would be a 2. Those two values can be divided by 2, right? If we check x to the power of 3 and x, we can take out an x from both of those. So I'm going to put a 2x on top. And then I move on to the last column. So for the last column, I need to check what can I take out of the 1x and the positive 4. So if you take a close inspection of these two things, these two factors, the only thing that goes into them is a 1. So that's it. So since the only thing that goes into it is a 1 and the first number is positive, then I'm going to put a positive 1 on top. Okay, step 5 is the most important step. If you go back to step 5, check your box to make sure that it makes sense. So let's check it. So let me check the multiplication really quick. So x times 2x, does that give me 2x to the power of 3? That is a yes, so that works out. X times 1, does that give me 1x? Yes, it does, so that works out. 4 times 2x, does that give me 8x? Yes, it does, so that works out. And then 4 times 1, does that give me 4 on the last step? Yes, it does, so that works out. So our factors can be written as x plus 4 multiplied with 2x plus 1, but if you were to tell me that this is a final answer, this would be 100% incorrect. And the reason why this is incorrect is because we forgot about one major thing. At the very beginning of the problem, we said that we took out a greatest common factor, which was the 2, right? So if we took that out in the beginning, then that is going to follow us through the whole entire problem. So at the end, I need to include that as part of my factor because we took it out in the very beginning, right? So the whole simplified answer will be 2, which we took it out in the beginning, multiplied by x plus 4 times 2x plus 1. All right, so don't forget about every single term. Oh, actually, was there a mistake here? I feel like there's a mistake. Oh, there is a mistake. Apologies for this example. I made a huge mistake. Nothing too crazy, but it is actually right here. This should be 2x to the power of 2. And when I factor out the 2, I should get x to the power of 2 here, not x, which means that right here, when I put in these terms, that should be x to the power of 2, which means that when I factor out this x, I should actually be able to take out 2 x's from the first row, right? So it's just a domino effect of errors. So on the first row, I can take out 2 x's, right, from this term, not 1x. So that's going to change my answer a little bit. Nothing crazy, but now that should be x squared plus 4, not x. All right? Again, it's not a huge deal because if you remember, all we're doing here is we're basically doing multiplication but backwards. So if you want to check your answers when you have your final factors, all you have to do is multiply to see if it makes sense. So let me check. Any single answer that you get for these assignments, you could always check them by multiplying them out. So if I multiply 2 times x squared plus 4, I will get 2x squared plus 8, right? So this is the first two that I multiply together. Now, if I want to multiply this with the last term, which is 2x plus 1, let's do that. So 2x squared plus 8. If I multiply this with 2x plus 1, that should be my completely multiplied out polynomial. So to be able to multiply this, I need to draw a box. So now this time I'm going to be doing a box, but for the purpose of multiplication, so I can check my answer. 2x squared on one side, positive 8 on the other side. Doesn't matter what you write where. When I multiply this out, I get 4x to the power of 3. Here I get 2x squared. Here I get 16x. And then here I get 8 times 1, which is 8. Again, we need to combine like terms or the peanut. In this peanut, there are no like terms because here we have x squared and here we have x. So there's nothing that we can combine together. So we basically are done. We can skip to the final answer as 4x to the power of 3 plus 2x squared plus 16x because they're all positive, and then plus 8. All right, so this will be my final multiplication, which means that this should match up to my original polynomial. If I check my original problem, my original polynomial was indeed 4x to the power of 3 plus 2x squared plus 16x plus 8. Okay? And that's what we had here when we checked it with the box. So any single time you have a problem, you could always multiply it out to check your answer. All right, I hope this video was helpful on factoring polynomials by grouping. Good luck on your homework. See you on the next one.